Okay. Okay, first things first, there were a couple problems on the 2.6 practice 2 assignment that I want to just very, very briefly talk to you about. So this here, they want you to come up with, the question asks you to come up with the inequalities for both both of the inequalities, the one with the negative slope, which has the red boundary line, and the one with the positive slope, which has the blue boundary line. And it gives you it's multiple choice, so it gives you choices, but the choices are all in standard form. So let's just go through one of these really quick. How about the red one, the one that has a negative slope? We'll take that one as an example. So for the red one, if by just inspecting the boundary line, would you agree that I can see here that my y-intercept is 2, and if I create a slope triangle here, I'm rising by -2 and running by +5 in getting from this point down to the next point, right? If I make a slope triangle out of that. So my slope is -2/5. Now I can combine that information, and if I write the equation of the boundary line in slope-intercept form, it would be y is equal to, but we're not going to keep it as an equal sign, right? We're going to have to make it an inequality, but we'll start off with an equal sign for our boundary line. Y is equal to -2/5 x plus 2. However, it's not an equal sign because it's supposed to be an inequality. Well, if we're shading below, which we are, right? We're looking for the region that is below the red line and above the blue line. So how would I say below the red line? What would I have to do, replace the equal sign with here? What do you think? Akira, what would I have to replace the equal sign with?
Less than.
And it looks like the boundary line is solid, so
Or equal to, less than or equal to.
There you go, less than or equal to. Good. Okay, so there's my line, but it's just not in standard form. So now I've just got to get this thing into standard form, right? How am I going to clear the fractions and put this into standard form, Alara?
Would you multiply by 5?
You got it. That's it. I'm going to multiply by 5 to clear all the fractions because my common denominator is 5 this time. Well, if I distribute that 5, I get 5y is less than or equal to 5 times -2/5 would just cancel the 5 on the bottom, so I get a -2x, and then 5 times 2 is 10. Okay, we're getting there. I've just got to get it into standard form. What's the one other thing I've got to do to put this in standard form, Tony?
Would you add a 2x?
Add 2x to both. I got to move that 2x over, don't I? So I'm going to add 2x to both sides. And that's going to give me 2x plus 5y is less than or equal to 10, right? So which one of those does that match? They've got them mixed up, right? Which is okay, but it would match that one, wouldn't it? Everybody see that? Okay, so that's how you're doing that one. Okay, the other one I want to look at is the last one on, and this is kind of almost a bonus question, but I want you to see this. I think this is kind of important. So a small truck can carry, it tells us a small truck can carry no more than 1,300 pounds of cargo or 120 cubic feet of cargo. It tells us that a printer weighs 20 pounds and occupies 3 cubic feet of space. A microwave weighs 30 pounds and occupies 2 cubic feet of space. Now, I didn't write the rest of the question, but what it's wanting you to do is make a graph of the system, write down the system of linear inequalities and graph it to represent all of the possible combinations of printers and microwaves that the truck could carry. Excuse me. So we will define, say it again, Jade. Sorry, I missed that. Oh, okay. Okay, so we'll define X and Y in this case. Those are the unknowns or the variables. Those are just the numbers of devices that we're carrying in the truck, right? So X would be something like the number of printers, how about? And Y is the number of microwaves, okay? So in terms of the number of printers and the number of microwaves, how are we going to make some statement up here that says that the weight of all the cargo that the truck is transporting is no more than 1,300 pounds if we know that a printer weighs 20 pounds and a microwave weighs 30 pounds? How could we maybe come up with that, Tony?
Would you do 20x plus 30y is less than or equal to 1,300 pounds?
Perfect, right? So the cargo weight would just be 20x plus 30y, 20 pounds for each printer times the number of printers, which is x, plus 30 pounds per microwave times the number of microwaves, which is y, is the total cargo weight. And that has to be less than or equal to 1,300. Good. And then by the same token, we could do something just like that for cargo space, couldn't we? We know that each microwave and each printer, and the number of printers is x. Each printer occupies 3 cubic feet. So then 3 times x would be the total volume of all those printers in our truck. Each microwave takes up 2 cubic feet. So 2y is the amount of space that all the microwaves take up. And that has to be less than or equal to the capacity of our truck, which is 120. Okay? Give me 1 to 5 on that so far. How are we doing? And just type it in. If you're not going to flash me fingers, just type it in real fast. See how quick we can get these done. Okay? Okay, that's very helpful. Thank you. Getting it quick like that really helps me. Okay, so now that looks pretty good. But remember, we talked about on Tuesday, we were looking at some stuff on inequalities. I think we were looking at a problem where we had apples and oranges. And I mentioned that something that's really important when we're dealing with physical things like this, like we can't have a negative number of something physical, right? I can't have a negative number of printers or a negative number of microwaves. That doesn't make physical sense. I know that when I'm talking about physical things like printers and microwaves, the number always has to be non-negative of those things. So it could be 0 or greater, but it can't be negative. It doesn't make sense. How could I add a third inequality here that's going to tell me that the number of printers can't be negative? What do you think? Aurelia, do you have an idea for that? Because I could.
What was the question again?
So I want to come up with an inequality that says that the number of printers can't be negative. I could have no printers, right? But I can't have a negative number.
X less than?
So
or
now I'll give you.
I'm a little confused.
Okay, that's fine. Let me give you another hint that might be helpful. So 0 is the boundary between negatives and positive, right? Okay, so we know that the number of printers can't be negative. It could only be 0 or positive, which really just means 0 or greater, doesn't it? So how could you say that is an inequality then? X is
Greater than or equal
to 0, right?
Yeah.
Okay, does that make sense? So that's saying X could be 0 or it could be greater than 0. That makes sense, right? The number of printers could be 0. Maybe he's transporting no printers. That's possible. Or maybe he's transporting some positive number of printers, but X could never be less than 0. That would be a negative number of printers, which makes no sense, right? And then we could do the same thing for microwaves, right? We make a similar statement about microwaves. Y is greater than or equal to 0. And now we've got our system there, okay? Does that make sense? Everybody? Okay, so if we graph that, then we would get the region where that we would get the region that describes all of the possible number of printers. And I'm just gonna do this real quick on Desmos because I want to show you one other feature. Excuse me. Need a drink of water. Okay. Okay, so if I enter this system, here's my first inequality. Here's my second. Oh, there we go. 3x plus 2. I zoom out, I can see that a little better, right? Okay, that's kind of messy looking, but you can see there that the region we're interested in is the region that overlaps with all 4 graphs, right? It's that quadrilateral looking region in there, okay? And so we would know then, for example, that the point, what are the points that are included? Some solutions that are a part of the solution would be, for example, like if I went over 30 and up 10, that works. Okay, there's an example of a point that's in our solution. So we could transport 30 printers and 10 microwaves, right? Another one that works is the point 0, 0, right? I mean, I could transport 0 of either one of them. It's not much of a load to carry, but it doesn't, the van could do it or the truck could do it. It could carry nothing. But something that it couldn't do, it couldn't carry, like let's say 30 and 30. That doesn't work. That's outside of our solution, right? And so our truck is not capable of transporting 30 printers and 30 microwaves. It doesn't have the capacity to do that. Either it's too much weight or it takes too much space or both. Anybody see that? Okay, give me 1 to 5 on that. Does that make sense? Okay, good. The other thing that this question asks about, which is a little goofy, is it wants to know the equations of all, or the coordinates of all the corner points, which is kind of a weird thing to ask. I know why they do it, but it's not important for us. So remember, to do that, all you have to do is just click on those points and they'll show up, right? So I could just do that in Desmos to find those points. Okay? All right, I'm gonna take a picture of that for our notes. Okay, moving on. So what about something like this? Determine whether the given ordered pair is a solution of the system. Brogan, how do I know if that ordered pair, 1, -5, is a solution of the linear system there that has those 2 equations in it? How would I know? Would you just plug them in? That's it. Plug them in. Exactly. And I have to plug it into both equations. So all I'd have to do, and you can use Desmos for this. On the test, you will have the Desmos scientific calculator available the entire time. You'll only have the graphing calculator for the last, kind of like about the last half of the test. But you don't need the graphing calculator for this one. You just need the scientific one. You don't even need that. But it's helpful, right? So I could just plug in 1 for x and -5 for y, and be sure that you always enclose values in parentheses when you're doing this. When you're evaluating something, put the number you're plugging in parentheses so you don't make sign errors, because it's really easy to do, okay? And if I do that, look what I get. I end up getting 7x plus 5y becomes -18, which is the same as the number on the right. So that works, doesn't it? The ordered pair satisfies the top equation. However, when I plug it into the bottom equation, it doesn't work. I end up getting 12 on the left side and 10 on the right side, and so those don't match up. And so it's not a solution of the second equation, which means that it's not a solution of the system, because it has to work in both to be a solution of the system, right? Okay, don't just ignore this if you want to. This is really just kind of a bonus topic. If you really want to be tricky with this and try something technological, you could define a function of two variables and plug in those two values to figure out. But it does, honestly, that's really probably not worth it. I wouldn't even bother with that. I just thought I'd show it to you just so anyone who's interested has seen it, but it's not important. I would just do it the top way. The way Brogan suggested is the best and easiest way. Okay. How about one like this? Solving systems. Solve the system by either elimination or substitution. Verify your work by using Intercept on your graphing calculator or Desmos, but you won't have that on the test. You would be able to plug values into the equations, though. So you could use the Desmos Scientific to just plug numbers in and see if they work. But you won't be able to graph it on this problem on the test. Okay, so let's talk about how to solve this one then. Are we going to want to use elimination or substitution here, Jade? What do you think? Which method would fit this the best? Questions for Jade.
Elimination?
Well, we always could, but it's a lot more work in this case. The answer is substitution, but can you tell me why?
I'm not sure.
Okay, that's all right. Okay, so James Weller, can you remember when substitution is a good idea?
Not at this very moment.
Okay, that's okay. How about James Thatcher?
You have the x by itself.
Yeah, good.
The value of x back into it.
Okay, perfect. Yeah, so we want to use substitution whenever it's convenient to do, which means whenever it's easy to isolate a variable, right? Because that's the whole point of substitution, is we're going to isolate a variable in one equation and plug it into the other one. So we would only do that when the coefficient of the variable was 1 or -1. And in this case, it's actually done for us, right? This one's already solved for x. So we would just put a box around this. This is our substitution equation. And then that's what we're going to plug into for x in the other equation, right? So our top equation would become -7 times x, and we're going to plug in a value for x, plus 6y equals -43, where x is equal to 4y plus 3, right? And now look what that did. Now we have a new equation here that's only got y's in it, and so we could do some algebra and solve for y, right? We would just distribute the -7 and get -28y minus 21 plus 6y equals -43. And I could combine like terms here, couldn't I? Negative 28y plus 6y is negative 22y. Minus 21 equals negative 43. And then from here on out, I won't even ask you guys. This stuff is, you know how to do this stuff. I'm just going to add 21 to both sides. And we get negative 22y is equal to negative 22. So if I divide each side through by negative 22, I get the negative 22's cancel, and everybody agree I just get y equals 1. James, what am I going to do now where do I go from there with substitution method?
You put the 1 in for the y values.
Good, and I know where to go because I put a box around my substitution equation. So I go right back to that and I plug that in. So that's going to give me x equals 4 times, good, 4 times my y value of 1 plus 3, which is 7. So then my solution would have to be the ordered pair, right? We're going to have to include both the x and the y values. And so we get the ordered pair 7, 1. And you should definitely check that, right? I give you the gift on tests of no time pressure. So you always have the option to take your time and plug in your solutions to see if they work. You definitely should, right? You'll know if you got it right before you ever hit submit. I'm not going to take the time to do it here because I want to get through lots of practice problems with you, but you should. What about this one? Lindsay, which method would we use on this one? Elimination or substitution?
Elimination.
Yes, elimination for sure. It's not easy to isolate a variable here, is it? They all have coefficients that are other than 1 or negative 1, so we don't want to use substitution. Okay, so what do you think? Lindsay, what variable would you choose to get rid of here? There's not much of a difference on this one, but one of them is ever so slightly easier than the other one to eliminate. Which one would you eliminate?
Y.
Yeah, good. You eliminate y. Good job. Okay, so I'm going to eliminate the y and think just remind yourself real quick, what are we doing with elimination, right? Our goal is we want to multiply either one or possibly both equations by the smallest numbers possible so that we can get equations where I have opposite numbers of x's or y's, so opposite coefficients. So when I add the two equations together, either the x's or the y's will cancel, right? In this case, we're getting rid of the y's. So I want to build, my goal here is to build the smallest coefficients of y by multiplying both equations in this case, so the y's will cancel. What are you going to multiply the top by here, Lindsay? To get those y's to cancel, I'm going to have to, what's the smallest number that 3 and 5 both divide into? You still with me, Lindsay?
Sorry, what did you say?
So I want to know, what am I going to multiply the top and the bottom equations by? What am I going to multiply the top one by? If I add these equations up right now, look what happens. I don't get a good result. The x's don't cancel. I get a 9x. 5y plus negative 3y is minus 2y. And here I get a 3. Well, that's no good. I have to get the x's or the y's to cancel. So I've got to multiply the top by something and the bottom by something so that when I add the equations up, the y's will cancel. So what do you think? Do you have an idea? And you can pass if you need to. That's fine. Do you have an idea, Lindsay, what I should multiply the top by? No, you're okay. McKenna, want to help her out?
I'm not sure.
Okay, yeah. How would you know, right? That's a good question. It seems like that's a question a lot of people are having here is how do you know what to multiply the equations by? Well, if I'm getting rid of the y's, I want to multiply the top by a number and the bottom by a number so that I'm going to get opposite.
Would you do 3?
You would do 3, exactly. Good. I'm going to do 3 on the top. If I multiply 3 through both sides, so distribute it all the way through, I'm going to get a 12x plus 15y equals negative 33. So then what would I multiply the bottom by? Because I already know that in order to get the y's to cancel, I'm going to need to have a negative 15y there, right? So what do you think?
That would be 5.
5. Good. If I multiply 5 through, I'm going to get 25x minus 15y. Bingo. Look what happens. That's what we want, right? We want the y's to cancel. Equals 70. And so the y's canceled. And when I add these up, I get 37x equals 37. And so if I divide each side by 37, what am I going to get, McKenna, for x?
Would it be 1?
Yep, it's 1, isn't it? I'll divide each side by 37 and I get 1. Okay, so the y was slightly better. If I were going to get rid of the x's, does everybody see that I would have had to multiply the top by 5 and the bottom by negative 4, something like that? And so I'm multiplying by slightly bigger numbers. 3 times 5 is 15 and 5 times 4 is 20. Well, 20 is bigger than 15, so I'd rather multiply by smaller numbers, wouldn't I? So it was a very slight difference, but the y is a little bit easier to get rid of. Okay, once I know that x equals 1, what am I going to do next with that? Let's see, Melinda?
Would you plug it back into one of the equations to find your y?
There you go. Good. So I'm going to plug it back into either one. We'll just plug it into the bottom one. How about? And that's going to give us 5 times my x value minus 3 times y equals 14. And the x value I'm plugging in is 1. So 5 minus 3y equals 14. Now we just solve for y, right? So this is just 5. I'll subtract 5 from both sides and get negative 3y is equal to 9. Divide each side through by negative 3. And I get my answer y equals negative 3. So I've got my ordered pair then, right? I've got the ordered pair x equals 1, y equals negative 3. And I should check that by plugging it back in, okay? So that was a harder one because we had to multiply both equations by something. A lot of times it's easier. Like let's just take a quick look at these two examples. Like this top one here, I don't have to multiply anything, do I? Right? The way it stands right now, if I add these things up, whoops. Look, the x is already canceled, don't they? Right? I don't have to do anything. I would just add those up and get 6. And then you can figure it out from there, right? We could solve for y and plug it back in to get x, no big deal, okay? What about the bottom one? What about that one? What's going to be the easiest way for me to solve that one? What would you do with that one, Olivia? Got to use elimination, don't I? I mean, I don't have to. There would be a trick to do substitution, but elimination to me is the easiest. So questions for Olivia. Yeah, I want to know, how would I solve that with elimination? What would I need to do to get something to cancel there?
Subtract the x's?
Okay, so I want the x's. You're right. I'm going to want to cancel the x's, aren't I? Good. So what would I have to multiply by to get those x's to cancel? Right now, they don't cancel. If I subtract those equations, I'm going to get a 4x there. That's not going to work. I need them to cancel, right? So what would be the easiest way to get rid of those x's?
Multiply by 3.
Okay, the bottom one, right? Top one I can just leave alone. Top one I can just leave as 6x minus 5y equals 19. And now I need to get the x's to cancel, so I need a negative 6x there. So what am I going to multiply the bottom by?
3.
Almost, but if I multiply by 3, I'm going to get a 6x, and those don't subtract to 0.
Negative 3.
Negative 3, there you go. So that's going to give me a negative 6x minus 6y equals positive 36. And look, now that works, doesn't it? Then the x's cancel, and I get negative 11y equals 55. And you guys could all take it from there, right? Solve for y and plug it back in, okay? 1 to 5 on that stuff. How are we doing with elimination? Does that kind of remind you of what we were doing before break? I know it's been quite a while. Quickly, give me a 1 to 5 on that so I get some feedback. Okay. And if, this review I think is going to be very helpful, but if you want some additional, you want to go back and kind of review things a little bit more, remember all of the videos and the instructional notes are there, right? So take advantage of those if you need to. Okay, what about this? So we're graphing some inequalities here, right? When we graph inequalities, remember that we're always going to end up with a boundary line and a shaded half plane. So all this ever amounts to is graphing the boundary line and then shading to one side of that boundary line. For the top example, x is greater than or equal to negative 1. My boundary line is just going to be the line x equals negative 1, right? What does that line look like? What's that line look like, Owen? The line x equals negative 1.
Repeat that again?
Yeah, so we're trying to graph this top inequality up here. So the boundary line would just be the line x equals negative 1. Describe that line to me. What's the line x equals negative 1? So all of the x values would have to be negative 1.
I don't know.
Okay, Savannah? If I have a line x equals a number like that, what does that look like? X equals negative 1. Questions for Savannah?
Oh, sorry, I didn't know that you said my name.
Oh, that's okay. Yeah.
I'm not sure.
Okay, so if all of the x coordinates had to equal negative 1, remember, if I have x equals a number or y equals a number, those are the oddball lines, aren't they? Those are the ones that are either horizontal or vertical. You have to always just decide which one is which. So x equals negative 1. If every x coordinate is negative 1, is that going to make the line be vertical or horizontal?
I want to say vertical.
You're right. It'd be vertical. Yeah. Good. Okay, it'd be a vertical line because all of the x coordinates have to be negative 1, right? So the y could be anything, but if x is always negative 1, the line always, every point has to be 1 to the left of the y-axis. Good. And then what about the shading part? Well, if we want the x values that are greater than or equal to, well, because it's equal to, we make a solid boundary line. What about the greater than part? We know that the x-axis goes horizontally, right? So bigger x values are further to the right and lesser x values are further to the left. So this is just saying to the right of the boundary line, okay? And then what about y is less than -5? Well, Savannah told us that an x equals a constant is vertical, so y equals a constant we know has to be a horizontal line, which makes sense. The boundary line here, y equals -5, all of the y coordinates would have to be -5. So every point on our boundary line has to be 5 below the x-axis, right? So it's going to be a horizontal line. And if we want the y values that are less than that, we've got a dashed boundary line and we're shading below, okay? All right, let's get a little practice using the tool here. I want to pull up some sample problems from the test or the practice test. Okay, here we go. You've probably used this tool already, but I just want to, want to make sure you understand how it works. Oh, darn this thing. Okay, that'll work, I guess. So we want to graph this system of linear inequalities. So we click on this thing to be able to use this tool. And I can make it maybe a tiny bit bigger, can I? No. You guys see that okay? I know it's probably kind of small. So we're going to use this tool here, right? Well, a linear inequality consists of a boundary line, so we need the line tool, and then there's the paint bucket for us to shade a half plane, okay? All right, so this first one, can you tell me, Chavano, for this top line up here, what's the y-intercept and the slope for the boundary line? Questions to Chavano. Chavano, are you there? I don't think Chavano's with us. I'm going to move on here. Let's see, Akira. How would I graph that top line with my line tool? Where would I start?
Put it on -6 and then rise 2 and another one.
Okay, good. Perfect. There's my y-intercept. My slope tells me to rise 2 and run 1. Good. And I want a dashed boundary line, don't I? Because I'm not including the equal sign, so I got to make that a dashed line. Okay. And then I would be shading everything above, right? Now I might end up having to erase this, but I'm gonna go ahead and do this. So I'm gonna shade everything above, and that is my top inequality. Okay. What about the bottom one? For the bottom one, Alara, how would I graph that boundary line?
Start at 8 and go down 1 and over 1.
There you go. Rise -1 and run 1. Perfect. Okay, and it worked. I don't know why it worked that time. I got to make it dashed. It happened to give me the right, it shaded the right one. But what if it didn't? I can always go in here and individually, I'm going to show you a trick. I can go in here and delete the shaded regions and just keep the boundary lines, for example, right? Now, I would have wanted the boundary line above my first line and below my second. So does everybody see that that would be this region over here to the left, wouldn't it? Okay, so I could just choose the paint bucket and shade that region, and that's my answer. Okay? Everybody good with that? Okay? All right. So there's one like that. I think I want to do the next one. Yeah, I do. I want to do the next one too. And if this might be all we'll see. Might be the last one we get through. Okay, so now this one, what's a little tougher on this one with this linear system? Tony, what's going on here that makes this a little tougher?
Is it the first one is in standard form?
Yeah, look, both those lines are in standard form, aren't they? So I'm going to have to put these things into slope-intercept form in order to graph them, right? So let me take a picture of these. And then we'll go do that algebra and we'll come back and graph them. Okay, so Tony, what about this first one here? I got to put that into slope-intercept form. What am I going to do?
You would subtract the 3x and then divide everything by 6.
Good. So I subtract the 3x. That's going to give me 6y is less than or equal to negative 3x plus 6. And then I'll divide everything through by 6, right? And I'll go ahead and split this denominator up and divide each term separately. So I get negative 3/6 x plus 6/6. So I end up with y is, man, this dumb pen is less than or equal to, well, I can reduce that, right? Negative 3/6 becomes negative 1/2 x plus 6/6 is 1. So there's one of my two inequalities. And then the other one down here, this is really an easy one, isn't it? All I have to do here is just subtract 4x from both sides and I'm done, right? I just get y is less than or equal to negative 4x plus 8. Okay, so now with those two, let's go ahead and graph this thing. Now that we've put them into slope-intercept form. Oh, that's not working at all. Okay, we're just going to have to remember those. I can't, well, here's what I can do, I guess. Well, we'll just remember those. Negative, somebody write those down. Tony, write those down in your paper so you can read them back to me. There we go. Okay. So that first one was y equals negative 1/2 x plus 1, correct?
Yeah.
Okay, and y, so I'm going to do y is less than that. So negative 1/2 x plus 1. Everybody agree I'm going to have a y-intercept at 1. My slope is negative 1/2, so I rise by negative 1 and run by 2, and it's a solid line. Okay, so there's my first one. And I could shade, if I want to shade right now, just to see what it looks like, I can shade below. The other one was y equals negative 4x plus 8. Was my boundary line. So there's 8. My slope is negative 4, so I rise by negative 4 and run by 1. And I wanted to shade everything below that one also, right? So that's the correct region then, isn't it? Everybody agree? Because that's the region that's below both of those lines. Everybody with me on that? Okay. So I'll save it and check it, and what do you know? Okay, let me take a picture of that. for our notes. How about? Okay, there it is. All right, last one. So now we're into the graphing part of this. The graphing part gets, a lot of this is pretty quick because I can use Desmos Graphing on this. With Desmos Graphing, all I've got to do here, in fact, actually, I think I've even got, hang on. Oh yeah, there we go. Okay, it pulls it up, and there it is. All I would have to do here, this is very simple. I'm just going to enter the two linear equations, and then I just need to find the point of intersection, and there it is. Okay. There. Okay. And they want you to round this. Make sure you read the directions carefully here. They want you to round it to the nearest hundredth, so 2 decimal places. So my answer in this case would just be, here's my ordered pair, right? It would be the ordered pair negative 1.14, comma, negative 3.57. Okay. Questions on that? Does that make sense? Oh, what great timing. How about that? So I'll be here after school. If you have any questions or you need to test or retest or anything like that, come see me, please. If I don't see you after school, I will see you on Monday. Have a great day.